Welcome to The Explainer. Today, we're going to dive into a world of technology that is literally all around you every single second of the day. But here's the thing, it's designed to be completely invisible.
So think about this for a second. You've got a watch on your wrist, a critical safety system in your car, and, a simple kitchen appliance. I mean, on the surface, they couldn't be more different, right? But underneath it all, they share a pretty powerful secret. That's right. Every single one of them is powered by a small, dedicated computer that you never, ever see or even think about. And these hidden computers, well, that's exactly what we're going to unpack today. The truth is, we're surrounded by these specialized little computers. They're just working away silently, tirelessly, performing these very specific jobs that make our modern world, well, function. So, what do we actually call these hidden workhorses? It's time to give this invisible computer its proper name.
Okay, so here's the formal definition. It's a system that has both software and hardware, and it's designed for specific tasks. And that last part, specific tasks, that is the absolute key. That's what makes these things fundamentally different from, say, your laptop or your PC.
An even simpler way to put it, just think of it as a computer with only one job. That's it. Your coffee maker system, its only job is to brew coffee at exactly the right temperature. Your car's anti-lock braking system, its only job is to stop the wheels from locking up. They're specialists, not generalists.
So how do these single-job computers actually work? What's going on under the hood? Well, let's break down the machine.
Turns out every single embedded system, and I don't care if it's in your microwave or a satellite orbiting the Earth, is built from just three fundamental parts. And here they are. You've got the physical hardware and its software, you've got the application software that gives it a purpose, and then you have a special kind of operating system to manage the whole show. Let's dig into each one. Okay, first up, you have the physical brain, a microprocessor. But its instructions aren't sitting on a hard drive. No, the software is permanently embedded right there on a chip, something like ROM. This is what makes the whole system so fast, so reliable, and totally self-contained. Next is the application software. So if the hardware is the body, you can think of this as its to-do list. It's the specific set of instructions that tells the system exactly how to do its one single job. For, say, a digital thermostat, this software is just constantly reading a sensor and deciding when to kick the heat on or off. And finally, we have the manager, the real-time operating system, or RTOS. You can think of it like a traffic cop for information. Its whole job is to supervise the application and make sure the most important tasks happen exactly when they need to. In a car's airbag system, for example, the RTOS makes sure the deploy airbag command gets absolute priority over everything else. It's all about timing and what's most important right now.
Now let's zoom back in on that hardware brain, because, just like you wouldn't use a hammer to drive a screw, embedded systems need to choose the right processor for the job.
You have your general purpose processors, which are kind of like the jack of all trades you'd find in a laptop. But then things get way more specialized. You have application-specific processors that are tuned for certain things, like processing audio. And then, at the very far end of the spectrum, you've got the ultimate specialists, single-purpose processors. And these SPPs, they're designed to do one tiny function, but do it extremely well. A coprocessor might only handle graphics calculations, to take the load off the main processor. A controller might just manage how data moves around. They're all tiny, super efficient experts.
Okay, so we've seen the tiny components, we've seen the specialized brains, but let's zoom all the way back out. Why does any of this hidden world actually matter to us?
This right here, this is the statistic that really puts it all into perspective. A staggering 98% of all microprocessors made today go into embedded systems. Just 2% go into the computers we actually see, like our laptops and desktops. We are, and this is no exaggeration, living on a planet run by these invisible computers.
From our homes and our cars to life-saving medical equipment and massive industrial machinery, embedded systems are the quiet, reliable engines that make all of it possible. They really are the foundation of our entire technological society.
So the next time you start your car,
or use a remote control, or even just set your washing machine. Take a second and ask yourself, what invisible, single-job computer did I just command? Thanks for joining the explainer.